This is Algebra 1, and today we will be solving quadratic equations by factoring. To factor the polynomials into the product of two linear factors, we are going to be using the box method, and then the zero product property by setting each of our factors equal to 0. So inside the box is where we're going to place our trinomial. But we do have a problem because this trinomial has 3 terms and the box has 4 compartments. So there is a special way that we want to split up these terms so that all the polynomial is inside this box so that we can create 2 linear factors on the side of the box. So to start, notice the 3x squared term is first. So that's the first thing I'm going to type. And I'm going to insert equation to make this look a little better. So we'll do 3x squared. And then the negative 2 is the last term, and I like to put that one in as well. So I'm just going to put negative 2 here. Now, here's the tricky part. We have a term in the middle, negative 5x, that we need to place in the 2 remaining corners of the box. But we can't just put them anywhere we want. We have to put them so that they have a sum of negative 5x, but a product of negative 6x squared. Now, why does the product need to be negative 6x squared? Notice this term is 3x squared, and the term down here is negative 2. Well, if you multiply 3x squared times negative 2, you get the product, negative 6x squared. So that means the other 2 corners of the box must also have the product, negative 6x squared. So to do that, we're going to multiply negative 6x and positive 1x. Now, negative 6x and positive 1x do add up to negative 5x. You may wonder, why did we choose those 2 factors? There are other factors that have a product of negative 6x squared. We could have chosen 3x and negative 2x, or negative 3x and positive 2x, and those both have a product of negative 6x squared. But they don't add up to the middle term, negative 5x. The only pair that does both are the 2 we chose. So those are the only viable options. So once you've placed your trinomial inside of your box using these properties, the next step is to put linear factors on the side of your box. Now remember, this is the area of a rectangle inside here, and on the sides would be like your length and your width of your rectangle. So on the top of the rectangle, I need to put whatever common factors are in each of my columns. So notice on the left side, both of the boxes on the left contain a number divisible by 3. So that means the common factor is 3. I think I'll insert an equation to make that look better. Both of the boxes have an x in common, so the common factor is 3x. On the right side, you have a 1x and a negative 2, and they don't really have anything in common. So I'm just going to put a 1 there. On the left side, I'm going to look at the first row. What do the 2 terms in the top row have in common? Well, they have a 1 and a 3, so they're both divisible by 1, but you don't really need to write a 1. They also both have an x, so you have a common factor of x. So put the common factor x on the side of the box. On the bottom row, notice both of these have a negative. However, it doesn't matter if they both have a negative. If the first one has a negative, then you will always factor out a negative. So I'm going to factor a negative out. And then there's a 6x and a 2. Well, a 6x and a 2 have a 2 in common. So I'm going to put negative 2 for my common. Oh, I'm messing up here, sorry. Let me try that again. Negative 2 will be my common factor. Now, to be sure you're correct, you want to basically multiply your factors to make sure that they are equal to what's inside of the box. 3x times x is 3x squared. 1 times x is 1x. 3x times negative 2 is negative 6x. And 1 times negative 2 is negative 2. So I have found the 2 factors and the only 2 linear factors that will give me the same terms that are inside of this box. The next step in the process is to take each linear factor and set it equal to 0 and solve. This is the zero product property, which tells us that if 2 factors have a product of 0, that one of those factors must equal 0. So I've taken the factor on the left side of the box, x minus 2, and set it equal to 0. And I've taken the factor on the top of the box, 3x plus 1 is equal to 0. The next step is to solve. To solve the first equation, we would add 2 to both sides and get x is equal to 2. To solve the second equation, we would subtract 1 from both sides to get 3x equals negative 1, and then divide both sides by the 3, which gives us x is equal to negative 1/3. The second quadratic equation is 2x squared minus x minus 3 is equal to 0. We're going to place our squared term, 2x squared, in the top left corner of this box. We're going to take our constant, which is negative 3, and we're going to place it in the bottom right corner of this box. The next step of the process is to take the middle term, minus x, and use the remaining two corners of the box to represent the middle term, minus x. Well, the way that we do that is we choose two x's that have the same product as the terms that are already here, which is negative 6x squared, but have a sum of negative 1x. There's only one option. Only two terms that we can come up with have a product of negative 6x squared and a sum of negative 1x. The correct terms for the remaining corners of your box are negative 3x and positive 2x. That's because negative 3x times 2x is negative 6x squared, and negative 3x plus 2x is equal to negative 1x. Next, let's factor the trinomial by taking out common factors on the left and the top of this box. On the left side of the box, we have 2x minus 3. That's because the top row has a common factor of 2x, and the bottom row has a common factor of negative 3. On the top of the box, we have the binomial x plus 1. That's because in the left column, the two terms have a common factor of x, and in the right column, there's really nothing in common between 2x and negative 3, so we just put a 1, because you can always put a factor of 1. The next step is to take each of our factors and set them both equal to 0. 2x minus 3 is equal to 0, and x plus 1 is equal to 0. This is called the zero product property. We know one of these or both of these factors must be 0 for the product to be 0. So we solve each equation to find our two solutions to the quadratic equation. To solve this first equation, you would add 3 to both sides to get 2x is equal to 3, and then divide both sides by 2 to get x equals 3 over 2. In the second equation, x plus 1 equals 0, you would subtract 1 from both sides to get x is equal to negative 1. One way to check your answer is to type the left side of your equation into Desmos, and then look at your x-axis and make sure that it crosses the x-axis at negative 1 and at 3/2, which is the same as 1.5. Question 3. X squared plus 4x plus 4 is equal to 0. So in this problem, we're going to place our x squared term in the top left corner and our 4 in the bottom right corner. Now we need to fill the remaining corners of our box. The product of x squared and 4 is 4x squared. So these two corners have to have the product 4x squared. They also have to add up to the 4x that's in the middle term of this polynomial. The two terms that do that would be 2x and 2x. 2x times 2x is 4x squared. 2x plus 2x is 4x. Next, we need to place common factors on the side of the box. On this top row, the two terms have a common factor of x. So let's put an x. On the bottom row, the two terms 2x and 4 have a common factor of 2. In the left column, the two terms have a common factor of x. And in the right column, the two terms have a common factor of 2. To solve the quadratic equation, we set our factors equal to 0 and solve. But in this case, the factors are the same factor. So you really only have to set one of them equal to 0. X plus 2 is equal to 0 means we subtract 2 from both sides of the equation and get x is equal to negative 2. Now, what's different about this quadratic equation, since it has the same solution twice, We call this solution a double root. Question 4 is unlike the other 3 problems because in this problem we have a binomial equal to 0. But this is not just any binomial. It's called the difference of squares. Now take a look. X squared minus 9 is equal to 0. I've placed the x squared and the minus 9 in the box, as we always do. But what's missing is the x term, and that's because there's 0 x's. So that means the other 2 corners of the box need to have the same product of negative 9x squared, but they also have to add up to 0. So the only terms that would do that would be positive 3x and negative 3x. Positive 3x and negative 3x add up to 0, and that's why there is no x term in this polynomial. So the other 2 corners of our box have a 3x and a negative 3x, which means our factors must be x plus 3 and x minus 3. That's because the bottom row has a common factor of 3, the top row has a common factor of x, the left column has a common factor of x, and the right column has a common factor of negative 3. Next, set each factor equal to 0 and solve. And finally, our last 2 solutions will be x is equal to negative 3. That's because we subtract 3 to solve x plus 3 equals 0. And then x is equal to positive 3. That's because we add 3 to isolate the x in the second equation.